Hi, everybody. Mr. Hayes. We're back. We're wrapping up the first week of the AP Stats Review. This is Mr. Hayes' World of Math. I've covered all the Stats Medics lessons, except for some from the last unit, because we ran out of time. But I have a link to this 3-week review course down below. It's got all of the notes we're going to talk about today. It's just a lot of the free response questions that you can get off the AP website, but I format them in such a way so that it models an AP test, and it's the most recent one, so hopefully they're going to be more representative of what you'll see on the AP exam whenever you are taking that. So we're going to go ahead and jump in. Unit 4, remember, was setting up studies and things like that, so that's what the bulk of this is going to be. So we're going to jump right in with the first question that comes from, apparently I hit the wrong button. Good job, Hayes. 2016. Alzheimer's disease results in loss of cognitive ability beyond what is expected of typical aging. A local newspaper published an article with the following headline: study finds strong association between smoking and Alzheimer's. A little bit slower, big results. The article reported that the study tracked medical histories of 21,123 men and women for 23 years. The article stated that for those who smoked at least 2 packs a day, the risk of developing Alzheimer's was a 2.57 times the risk of those who did not smoke. So identify the explanatory and response variables. When we did this in my class, everyone was just like boom, boom, boom. Explanatory and response variables are something that typically are covered better now, starting with Algebra 1 and up. So this shouldn't be, hopefully this isn't a change for you. Explanatory variable, what is causing the problem? It's smoking 2 packs or more a day. The response variable, what is changing because that is happening? And it's the development of onset of Alzheimer's. So again, not a big surprise there. For part B, is the study described in the article an observational study or an experiment? Take a look. Think about it. The big idea with an experiment, what happens? You're right. A treatment happens. And since there is no treatment here, it's going to be an observational study. You're just looking at the results. We can't say for sure it happens, but we can say there's an association between the two. It seems to look like something's important. And then we jump over. Oh, it is down here. Sorry. So exercise, regular weekly exercise versus no regular weekly exercise, was mentioned in the article as a possible confounding variable. Explain how exercise status could be a confounding variable in the study. Now, I circle that, and I'll get back to that important part here in a second. But let's talk about the answer first. Exercise affects health status, so therefore it could impact the development of Alzheimer's. The fact that people are exercising might impact whether or not they develop Alzheimer's. Also just as likely is that there could also be a connection between smoking and exercise. So as an example, people who smoke may not exercise as much as those who don't. And the reason why I circled that was this. I had some students who were talking about other confounding variables. Remember to answer the question that's being asked. So you need to connect exercise with what's going on. You do this 2 ways, and this was brought up in class, and I was amazed at how profound this was. So good job on you. You know who you are. You need to treat exercise as the explanatory variable and how it can change the response variable. Okay, and that's what we did in part 1. You also need to say how the original explanatory variable, in this case smoking, could affect what's going on and affect exercise. Because if exercise does impact what's going on in terms of Alzheimer's, the fact that the original explanatory variable might be changing a different response variable, in this case exercising, which then could also then link into what's going on at the end, is huge. So you need to kind of treat whatever confounding variable that they're mentioning and link it both to the response variable and also to the explanatory variable. Okay? So that takes care of our first question. The next question is from 2014. As part of its 25th reunion celebration, the class of 1988, students who graduated in 1988, a state university has held a reception on campus. In an informal survey, the director of alumni asked 50 of them about their incomes. The director computed the mean income of the 50 attendees, and it turned out to be $189,952. So in a news release, the director announced, the members of our class of 1988 are enjoying resounding success. Last year, mean income of its members was $189,952. Okay. I'm sure you already know what is so wrong with that. But again, remember, as I said before, answer the question that's being asked. What would the statistical advantage of using median to report the incomes rather than mean as the estimate of income? The median isn't affected by outliers. So one really high or really low, but in this case, since he's the director, I guess it's not a he, the director of the director of what? Oh, director of alumni development is like, hey, look how great this is. So you can assume that it's going to be on the high end. So with one mean, one large outlier could skew the whole series of salaries that way, okay? And so that would be enough to answer the question that's there. For part B, the director felt members who attended the reception may be different than the class as a whole. Yeah, exactly. That's another thing that could be wrong with this, right? So they ask you for two ideas or ask you for your ideas on two different methods. One is they're going to email everybody and ask for them to respond. They estimate at least 600 people are coming back from that. Method two is simple random sample of members of the class. They're going to call by phone. Since it takes more time, then they're only going to try to get to 100 people that way. Okay, so which of the two methods would you select for estimating the yearly average of the class of 1988? Explain your reasoning. Now, the first thing that I had them do in class, and I'm going to apologize, this isn't really written out. It was I was having them to kind of do what's good, what's bad, and then we talked about how you would write it up. So I will do the same here. So method one is biased. So people immediately jumped on, there's non-response, there's voluntary response, all of that other stuff. So there's issues there. Somebody also said, however, it was beneficial because it's a larger sample. The larger the sample size, the less variation, et cetera, et cetera, et cetera. For method two, people were saying it's really nice because it's random sampling. But if obviously a downside is that it's a smaller size. So the question is, which one would you pick? The class ultimately picked correctly that method two would be better. Because while the sample size is smaller, the random sampling is going to cut out of a lot of bias. The other question, and I think we have an arrow down here that goes in, is the smaller sample size still big enough to take care of a whole bunch of things? 100 people is a good size. I mean, we're still bigger than 30, and you're probably going to get a rather diverse group of people out of the 6,000 plus people in the class for that. So when you go through and you say this, make sure that you mention that method two is better. It gets rid of the bias, and even though it's less people, it's still going to be large enough to be able to get a representative sampling of alumni from the class of 1988. Okay. One last question for you. We're going to jump to, I think it's 2013, I'm sorry. Administrator, a large university wants to conduct a survey to estimate the proportion of students who are satisfied with the appearance of university buildings and grounds. So they are going to ask the first 500 people who go to, well, actually, they're going to talk through it. They want to ask 500 students out of the 70,000 people who are attending the university. So one of the thoughts was, all right, because of financial constraints, we are just going to ask the first 500 students who show up at the next football game. And then they ask you why might such a sampling method be bad? Again, you can jump on this pretty quick, I would imagine. But just to be clear, and I really want to point out some of the pluses, one of the things you need to stress for the exam readers here. Okay, a couple of things here. First of all, the 500 students most likely won't be representative of the school population. Good. So as they arrive early, they might have more school pride than others. You may also mention something like you like school sports. That may have an impact of what's going on versus people who don't like sports. The athletic buildings might be newer than other buildings, that type of thing. But because of this, because they arrive early, they might have more school pride than others. And because of this pride, sampling of students those students might be more satisfied with what's going on than the student body as a whole. Okay, and actually more satisfied with what? The appearance of the buildings and grounds. So the two things that you need to do here is this. First of all, you have to state that the first 500 won't be a representative sample. So that's the first part that's important for full credit. Essential knowledge on this. The second part is because, and what might that group have? They might have more pride. So whatever they have, what might be different about that sample versus the whole population as a whole, how might that impact directly, and then go back to the context. So these people might have more school pride. That will then impact with what's going on. Or again, with the sports thing. These are avid sports fans. They may be around the sports areas of school campus more. Oftentimes, those are the nicer areas because those are the seen by the public more. So therefore, they will have a better impression about what the appearance in buildings and grounds will be like. Okay, so why is it not a representative of the population? And then how will that fact impact the results that we're trying to get? In part B down here, because a large number of students in the university, second method of the administrator is considering consists of using a computer with a random number generator to select a simple random sample of 500 from a list of 700,000. Describe how to implement such a method. Pretty straightforward. Assign all students a number from 1 to 70,000. Use the random number generator on the computer to get a random list of 500 numbers that don't repeat or without replacement, and then contact the students who correspond to those numbers. Okay, so again, you have to say, how is the population going to be numbered? How is the sample going to be taken? So again, random number generator, if it's smaller, you can put numbers in a hat, whatever. You don't have to get into a lot of detail, but just say, this is the way I'm going to do it. And then after that, make sure that you say that those are the people you're going to contact and relate it back to the population. All right. Now page down will work. So because it worked too well. Because stratification can provide more precise sampling, a more precise estimate than a simple random sample, the third method the administrator is considering is selecting a stratified random sample of 500 students. Again, now in your head, you should be thinking, okay, that means we're going to break up the population and then simple random sample within those populations. The university has 2 campuses with male and female students at both campuses. Under what circumstances would stratification by campus provide more precise estimate about the proportion of students who are satisfied than the appearance than universities or buildings or grounds stratified by gender? All right. Couple of things. Stratification here by campus would be important if there were greater differences in the opinion of the buildings and grounds between the students of the different campuses rather than between the genders. Okay, so if you're seeing a difference that one campus is liking what they're seeing more than the other, then it would make a lot more sense to go through and do stratification by campus rather than by gender. So let's say if there's a difference of 10% between the 2 campuses, but 3% by gender, definitely stratify by the campus. Yep, and that would be something like that. You could potentially get bogged down in terms of saying, well, one campus could be newer, so they may see it, and that would probably be fine, but you need to be specifically say that there is a difference, that the differences between the campuses are bigger than what's going on by gender. You do need to mention both characteristics, and if you don't, then you're only going to get a partial on this section here, which then would keep you from probably getting a 4 on the question. So again, you need to say this needs to be done because we're going to see a bigger difference between the 2 campuses, and that bigger difference is going to happen more. It's going to be bigger than what you're going to see between the 2 genders. Okay, so that's section 4, chapter 4 from Practice of Statistics, done, covered, ready to go. My classes, we're going to be practicing some multiple choice, and we're going to do the assessment after this, and then we will start chapter 5 after that. So it may be a couple days if you're waiting online for that. I will see if I can get something up earlier than that, but I can't promise anything. Sorry. So good luck with your assessment. If you have any questions, drop a link down below or drop a question down below, like, subscribe, whatever. You know the drill. But I appreciate all the support, and we'll talk to you soon.